Imagine learning for the first 18 years of your life that the Earth is flat. All through elementary school and high school you grow up hearing about the flat Earth we live on and doing boring flat Earth physics homework, and then, if you're lucky enough, you get to college and, psych! For the first time they show you a globe and say, sorry for lying, the Earth is actually round. Well, this is, unfortunately, exactly what we do with... You probably learned that objects attract each other based on their mass, so you probably grew up thinking that light can't possibly be affected by gravity because light is massless. I know I did. Well, guess what? The source of gravity is not mass. It's energy and momentum, which light certainly has. Of course, regular matter does too. So not only does light get bent passing by a star or planet or black hole, but light attracts the planet or star or black hole in return. To be sure, it's only a very, very small amount, but a small amount is not zero. Anyway, the point is that Newton's law of gravitation is just an approximation. Good enough to get us to the moon, but not perfect. General relativity is better. Speaking of the moon, you probably also learned that if a sheep is moving 2 miles per hour relative to a train, and that train is moving 2 miles per hour in the same direction relative to the ground, then the sheep is moving 4 miles per hour relative to the ground. 2 miles per hour plus 2 miles per hour equals 4 miles per hour, right? False. Experiments in special relativity have confirmed that velocities don't simply add together, and so the sheep will in fact be moving very, ever so slightly slower than 4 miles per hour relative to the ground. And the formula that correctly predicts this deviation from just adding the velocities is v1 plus v2 divided by 1 plus v1 times v2 over c squared. It's not a very big effect, but then again the Earth looks pretty flat, doesn't it? But the Earth isn't flat. If I walk 10,000 kilometers away from my cat, and you continue on walking 10,000 kilometers more, you're not 20,000 kilometers away from my cat. You're just 12,750 kilometers away. In fact, the farthest on Earth you can get from anything on Earth is 12,750 kilometers. It's the earthly distance limit, though we normally call it the diameter of the Earth. And similarly, when you try to add two velocities together, there's a cosmic speed limit of 300 million meters per second. That is, the speed of light. So just because to our eyes the Earth looks flat, velocities look like they simply add together, and light looks like it doesn't attract gravitationally, is that an excuse to mislead ourselves and our children about the true nature of things?